Robots are getting smarter every day. Scientists and engineers have built impressive robots. Considering that robotics have been used successfully in performing surgery, in warfare, and even in space exploration.
But even the most impressive robots need humans to control them, right?
Yes, most robots do need instructions from humans to perform tasks. However, the next revolution in robotics will be smart robots that can perform tasks on their own. However, there are some fields such as disaster relief that are not necessarily trying to eliminate human control of robots. The robots simply need to be able to act in dangerous places to reduce the risk of injury to rescue workers. In 1958, the United States Department of Defense created the agency called DARPA to ensure military technologies would be more sophisticated than those of potential enemies. DARPA is an acronym for Defense Advanced Research Projects Agency. To fulfill its mission, DARPA relies on its engineers to apply multidisciplinary approaches to advance knowledge through basic research and create innovative technologies that address current practical problems. DARPA's robots are involved in the fields of biology, medicine, computer science, chemistry, physics, engineering, mathematics, material sciences, social sciences, neurosciences, and more.
So you have this mechanism, this machine, that looks perhaps like a person, that seems to be able to move perhaps like a person, but the truth is it has hardly any brains at all. The head is empty. With a human one-year-old, you have this dichotomy. You have a very large brain inside of a one-year-old that sort of doesn't know very much yet. And so what you see is tremendous memory, you see tremendous understanding of social cues, of language, things like that. Even though a one-year-old can't speak, they can usually understand what we say. In that way, our robots don't come anywhere close to the intelligence of a one-year-old. Where our robots are similar to a one-year-old is in their competence at locomotion and manipulation. When a one-year-old tries to walk up and down ramps or up and down steps, they often fall. And it turns out that our robots have about the same level of competence right now, going up and down steps and ramps roughly that same size. They fall roughly just as often. The first challenge all the teams face is reliability. They've only had 6 to 9 months to build their robots, to begin to write software for them, to try to make them work. For the teams bringing their own hardware, that's the #1 issue. For the teams using the Boston Dynamics hardware, they have to deal with reliability of software, and that's no easy task either. So I think the hardest task that they have is making sure that all the bugs in their systems, hardware bugs, software bugs, won't end up losing them points in the challenge. Even a year from now, robots will not be able to leap mountains in a single bound. Robots will still move around relatively slowly. They will still fall on occasion. They will still need human supervision. Again, perhaps the robots will have brains that are roughly comparable to, I don't know, somewhere between an ant and a mouse, okay? They'll still be really, really dumb compared to human beings. They're still going to need human beings to tell them which particular tasks to do. They won't be able to figure it out. But we think that for disaster response, where we do have human beings, but they have to work at a distance from the robots to stay out of harm's way, we think that that pairing, that collaborative working relationship can be quite effective.
I learned that they have robotics competitions to find the best designs.
Yes, at DARPA they host the DARPA Robotics Challenge, a competition of robot systems and software teams that develop robots capable of assisting humans in responding to natural and man-made disasters. Some of the most advanced robotics research and development organizations in the world compete in the DARPA Challenge. Scientists and engineers collaborate to develop the hardware, software, sensors, and human-machine control interfaces that enable their robots to complete a series of challenging tasks. The winning team receives a $2 million prize. In the competition, robots are required to navigate a circuit of consecutive physical tasks with degraded communications between the robots and their operators. Robotic designs and technologies resulting from the challenge will transform the field of robotics and improve development and their ability to perform autonomous tasks in the hazardous, degraded conditions common in disaster zones.
How do they judge the competition?
Because disasters are often unpredictable in origins and effects, the type of robots DARPA envisions to aid in these situations must be adaptable and require 4 key capabilities to be effective. Mobility and dexterity to maneuver in the degraded environments typical of disaster zones. Ability to manipulate and use a diverse assortment of tools designed for humans. Ability to be operated by humans who have had little to no robotics training. And partial autonomy in task-level decision-making based on operator commands and sensor inputs. The trials for the challenges require that robots be highly mobile, easy to manipulate, and dexterous. In 1990, roboticists from the Massachusetts Institute of Technology formed iRobot to design and build some of the world's most important robots. They have delivered more than 5,000 defense and security robots to military and civil defense forces worldwide. Many of these specialize in performing dangerous search, reconnaissance, and bomb disposal missions to protect people from harm.
Cool! Is that one of those remote robots?
It sure is. iRobot is having success in the Remote Presence Robotics platform. The state-of-the-art AVA mobile robot delivers a new level of collaboration for office environments and other facilities, and RP Vita allows doctors to communicate with patients from virtually anywhere in the world. Honda is continually making progress in the field of robotics. Their humanoid robot, Osimo, an acronym for Advanced Step in Innovative Mobility, now has the ability to communicate in sign language and to climb stairs without stopping. Osimo was first introduced in the year 2000. Since then, Honda engineers have made significant advances. The most recent 4-foot 3-inch 110-pound Osimo has received enhanced stability and balance control, allowing the robot to climb more smoothly, run faster, and change directions with ease. Osimo has also seen improvements in the degrees of freedom available in its hands, which allows Osimo to perform many more intricate and precise tasks. This improved dexterity provides additional movement in each finger, which also led to the development of Osimo's new ability to communicate using both American and Japanese Sign Language. Osimo's hands also provide instantaneous feedback with new force sensors, allowing the robot to use the appropriate amount of force when performing specific tasks. It can pick up fragile objects such as paper cups without crushing them, but still allows Osimo to use a stronger force when necessary.
Robots are so cool. What if I wanted to work on robots one day?
A career in robotics can be exciting and highly rewarding. It is a fast-growing industry that will have a major impact on society in many disciplines. Going to school for engineering is the best path to pursue a career in robotics. Robots are evolving in a myriad of industries, and it is evident that they will assist us in many new ways, from the smallest of nanorobots in health-related fields to larger robots such as automated vehicles or those used in space exploration. Robotics technology has made extraordinary strides in recent years, representing huge opportunities which will have a very positive effect on society. As these technologies become integral to our daily lives, we will see the benefits even more in years to come.